Hello, this is Isaac, and today we'll be going over Part C, that is questions 21 to 25 of the 2023 Pascal Contest from Waterloo. I hope you can learn a thing or two in this video, and without further ado, let's get right into it. Alrighty, so let's get started with question 21. Starting with a positive integer m, Alicia creates a sequence by applying the following algorithm. Alicia writes down the number m as the first term of the sequence. If m is even, Alicia sets n equals half of m. If m is odd, Alicia sets n equals m plus 1. Alicia writes down the number m plus n plus 1 as the next term of the sequence. Alicia sets m equal to the value of the term that she just wrote down in step 3. Alicia repeats steps 2, 3, and 4 until she has 5 terms, at which point she stops. So for example, starting with m equals 1, Alicia's sequence would be 1, 4, 7, 16, 25. Alicia starts a sequence with m equals 3. What is the 5th term of her sequence? So for this question, I had the same solution as Waterloo, and that was to go through the algorithm. So first we need to understand it. Let's say we start with 1 as the first term of the sequence. This means that m equals 1. Next, we need to check if it's odd or even, which 1 is odd. So n equals m plus 1 in this case, which is 1 plus 1, which is 2. So for our next term of the sequence, it's m plus n plus 1. So 1 plus 2 plus 1 equals 4. Now we disregard all this and we set m equal to 4 because that's the next term of the sequence. We check if it's odd or even, which this time it's even. So we divide it by 2. So 4 divided by 2 is 2 again. So we add 4 plus 2 plus 1, which is 7. Now we disregard this. M equals 7. 7's odd, so n equals 7 plus 1, which is 8. Add these together. You've got 15 plus 1 is 16. And then disregard this. M equals 16. So n equals 16 divided by 2, which is 8. Add these together, 24 plus 1 equals 25. And if you notice, this is the same sequence as what was in the example earlier, so we know we're on the right track. So what if we started with 3, because that's what the question is telling us to do. So 3 is odd, so m equals 3, n equals 3 plus 1, which is 4. Add these together, plus 1, and you have 8. Now disregard this. M equals 8. 8 is even, so n equals 8 divided by 2, which is 4. Add these together, plus 1. You've got 13. Disregard this. M equals 13. 13 is odd, so we add 1, which is 14. 13 plus 14 plus 1, you've got 28. Disregard this, and finally for our final step, m equals 28. 28 is even, so n equals 28 divided by 2, which is 14. 28 plus 14, which is 42, plus 1 is 43. So 43 is the last term of the sequence, which is our answer. Alrighty, now on to question number 22. The integers 1, 2, 4, 5, 6, 9, 10, 11, and 13 are to be placed in the circles and squares below with one number in each shape. Each integer must be used exactly once, and the integer in each circle must be equal to the sum of the integers in the two neighboring squares. If the integer x is placed in the leftmost square, and the integer y is placed in the rightmost square, what is the largest possible value of x plus y? So I have the same solution as Waterloo again, and I'm going to start by drawing the squares and circles. This will be x, and this will be y. And our numbers available are 1, 2, 4, 5, 6, 9, 10, 11, and 13. So we need x and y to be as big as possible, but they're both squares, so that means they have to add up to something else, so they can't be the biggest number possible, 13. We need the sums to be as big as possible as well, because the bigger the sums, the bigger x and y can be. So 13 will go in one of these two circles. So let's just put it here for now. So we need the biggest number possible in y that can add up to 13. So that can be 11 plus 2 or 9 plus 4, and then it just gets way too low. So I'm going to start with 11 plus 2. So we have this side. Now we go to the other side. For x to be as big as possible, the next biggest number is 10. But if x is 10, then nothing can be in the circle because there's nothing available bigger than 10, and 10 needs to add up to something. So 10 will go in the circle. Two numbers that can add up to 10 are 9 and 1. Since 9 is the bigger of these two, it can go in x. 9 plus 1. So now we've figured out the edges, and now we need to figure out the middle, see if it works. So we have 4, 5, and 6 left. 4 is the smallest of these three numbers, so it will go in the square, because if it goes in this circle, then these two need to add up to the circle, so we need 1 plus 3 equals 4, and we don't have a 3. And if it goes in this circle, we'll need 2 plus 2 equals 4, but we've already used our 2, so 4 needs to go in the center. And what's 1 plus 4? 5. And 4 plus 2 is 6. So we've used all of our numbers, and it all works together. So x equals 9, and y equals 11. So the biggest possible value for x plus y is 9 plus 11, which is 20. And that's our answer. Now for question 23. Diwa writes down a list of 4 integers. He calculates the average of each group of 3 of the 4 integers. These averages are 32, 39, 40, and 44. What is the largest of the 4 integers? Alrighty, so whenever you have integers that you don't know, you always use algebra. So for these 4 integers, I'm going to use A, B, C, and D. And for simplicity's sake, I'm going to put them in ascending order. So A is the smallest, and D is the largest. So Diwa groups these in 4 groups of 3. These groups can be A plus B plus C, A plus B plus D, A plus C plus D, and B plus C plus D. These are the 4 possible ways to arrange it. So since A, B, and C are the smallest 3 numbers, this one will have the smallest average, so it will be 32. Also, it's missing D, which is the largest number. So, the larger the number you're missing, the smaller your average will be. So this one is missing C, the second largest number. So it will have the second smallest average, which is 39. This one's missing B, the second smallest number, so it will have the second largest average, 40. This one is missing A, the smallest number, so it will have the largest average of 44. So in averages, you divide it by the amount of terms that there are, and there are 3 terms in each one, so each one is divided by 3. So now to simplify it, we can multiply each side by 3. So this will give us A plus B plus C equals 96. A plus B plus D equals 117, which is 39 times 3. A plus C plus D equals 120, 40 times 3. And B plus C plus D will give us 3 times 44, which is 132. Now we're going to use something called elimination, which, at least in my area, you learn in a course called Number Relations and Functions for grade 10. So elimination is when you take an equation and subtract it from another equation. So let's take the largest equation, B plus C plus D equals 132. And let's subtract the smallest equation from it, A plus B plus C equals 96. So on the right side, 132 minus 96 will give us 36. On the left side, you have a B on top and a B down low. So B minus B equals 0, so they cancel out. And also, for C, C minus C equals 0, so they cancel out as well. Now you have D minus A, which those don't cancel out. So you'll have D minus A equals 36, or A plus 36 equals D. Now this isn't enough to solve it by itself, so we'll have to do it again. So we'll use B plus C plus D equals 132 again, but this time let's choose a different one. And we'll choose A plus B plus D equals 117. So A plus B plus D equals 117. 132 minus 117 equals 15. And on this side, we can cancel out the two B's again, and we can cancel out the two D's again. But this time, we have C minus A equals 15, or A plus 15 equals C. Now it's time to use something called substitution, where you take a variable's value and plug it into an equation. So we'll just take this equation, because we haven't used it, and conveniently, it contains A, C, and D. So what we're going to do is we're going to do A plus, and then instead of putting a C, we can do A plus 15, because C equals A plus 15. So A plus 15 plus, and then instead of D, we can do A plus 36, because that's equal to D. So A plus 15 plus A plus 36 equals 120, because this equation equals 120. Now we can simplify by making 3A, because there's 3 A's on this side, and then 15 plus 36 equals 51, and this equals 120. Now if we subtract 51 from both sides, we get 3A equals 69, because 120 minus 51 is 69. Now we divide both sides by 3, you get A equals 23. Now, since we're trying to figure out the largest number is D, and we know that A plus 36 equals D, so we can use a simpler form of substitution. Instead of putting A plus 36, we can do 23 plus 36, because we know that A is 23 now. So 23 plus 36 equals D, so 59 equals D. And that's our answer. Waterloo solved it quite a bit simpler than I did, and instead of using A, B, C, and D, they used W, X, Y, and Z. Next, they multiplied each of the averages by 3, because they knew that all the groups contained 3 terms. So, they got 96, 117, 120, and 132. Next, they found the sum of each of the 4 variables by adding all of the groups together, equaling all of the averages together, like this. W plus X plus Y plus W plus X plus Z plus W plus Y plus Z plus X plus Y plus Z, equaling 96 plus 117 plus 120 plus 132. Waterloo didn't have to assign each average to each group because they knew that one of these groups equals 96, and one of these groups equals 117, one of them equals 120, and one of them equals 32, so they can just jumble them all up together to get this equation. So to simplify it, it's actually 3W plus 3X plus 3Y plus 3Z equals 465, which is these 4 numbers added together. If you divide both sides by 3, you get W plus X plus Y plus Z, equaling 155. Now for some context about the next step. If all of these numbers together equals 155, then if you subtract 3 of these numbers and what they correspond to, you will get the value of one number. This is what I mean. Let's say W plus X plus Y is the one that equals 120. So if W plus X plus Y equals 120, W plus X plus Y plus Z equals 155. This means that Z changes it from 120 to 155. So Z equals 155 minus 120, which is 35. So Waterloo did this with each of the 4 averages, 96, 117, 120, and 132. Or sorry, not averages, sums. So 155 minus 96 was 59. 155 minus 117 was 38. 155 minus 120 was 35. And 155 minus 132 was 23. And 55 is the largest of these 4. So 55 was the largest integer. Okay, on to question 24. Cube ABCDEFGH has edge length 100. Point P is on AB, point Q is on AD, and point R is on AF, as shown, so that AP equals X, AQ equals X plus 1, and AR equals X plus 1 divided by 2X, for some integer X. For how many integers X is the volume of triangular-based pyramid APQR between 0.04% and 0.08% of the volume of cube ABCDEFGH? The volume of a pyramid is equal to 1/3 of the area of its base times its height. So that may have been a little confusing, but I have a little diagram of the cube here to help us out. So this cube has edge length 100, so all the edges are 100. It also has Q, R, and P points, so when all these are connected it makes a triangle-based pyramid. What we're trying to figure out is how many different values of the integer X are possible when the volume of this triangle-based pyramid is a percentage between 0.04 and 0.08% of the whole cube. So I'm going to break this solution up into 3 parts. The first part will be setting boundaries for what the volume of the triangular-based pyramid can be. The second step will be simplifying the equations that the question gave us. The third step will be solving by using these first two steps. Starting with step 1, boundaries. The cube has edge length 100, and the volume of a cube is just its edge length times itself, or 100 cubed. 100 cubed is 1 million. So 1 million is the volume of the cube. So we need to find out what is 0.04% of that and what is 0.08% of that. Well, the percentage equation goes like this. You have your percentage, and then you have the total value that you're finding the percentage of, and then you divide it by 100. So if I grab a calculator, put in the percentage, that's 0.04, times the total value, which is 1 million, divided by 100, we get 400. So 0.04% of 1 million equals 400. And likewise, 0.8% of 1 million equals 800. So that means that the volume of the pyramid is greater than or equal to 400 and less than or equal to 800. So our first step of boundaries is complete. Now it's time for step 2. Simplify. So I've written on the little diagram that AQ equals x plus 1, AP equals x, and AR equals x plus 1 over 2x. With this in mind, we can remember that the question told us that a triangle-based pyramid is equal to its base, which is this part, times its height, which is this part, over 3. And its base is a triangle. And we should already know that a triangle is its base times its height divided by 2. So to calculate the triangular base, we need to find x plus 1 times x divided by 2. So let's write this out. This is the equation, but it can be simplified to this. Because x times x is x squared, and x times 1 is x. So this is the base of the triangular-based pyramid. Now the height is x plus 1 divided by 2x. So to find this, we need to find x squared plus x over 2, which is the base, times x plus 1 over 2x, which is the height. And now, because it's divided by 3, we need to do all this divided by 3. Another easier way to write this is x squared plus x over 2 times x plus 1 over 2x times 1 over 3. This is the same as dividing it by 3. So now we can multiply all the numerators together and all the denominators together. x squared times x plus 1 plus x times x plus 1. This is a great way to multiply expressions with multiple terms together. This will get us x squared times x, which is x cubed, x squared times 1, which is x squared, x times x, which is x squared, and x times 1, which is x. This can be simplified to x cubed plus x squared, actually 2x squared plus x. Now for the denominators, which are a lot easier. 2 times 2x is 4x, and 4x times 3 is 12x. So here we have x cubed plus 2x squared plus x over 12x. This is our volume, and if we look back to step 1, our volume is between 400 and 800. So, let's see if I can write this here. This is between 400 and 800. Now you may have noticed that this is an inequation, and just like equations, you can multiply both, or in this case, all sides by the same term. So we can completely remove this 12 by multiplying each side by 12. So 400 times 12 is 4,800. This middle term times 12, well, we just have to remove the 12. So it becomes x cubed plus 2x squared plus x divided by x. And then 800 times 12 becomes 9,600. And finally, for this middle term, we can easily divide it by x, because when x has an exponent and is divided by x, the exponent just goes down by 1. So, we'll still have 4,800 on this side, but x cubed divided by x becomes x squared. 2x squared divided by x becomes just 2x, and x divided by x is 1. So this is the simplest we can get the equation. So now our second step of simplifying is done. Now it's time for step 3. Solving. In the previous step, we determined that 4,800 was less than or equal to x squared plus 2x plus 1, which is less than or equal to 9,600. So now we're going to determine the least and greatest possible values of x. At first glance, I'm thinking that the 2x plus 1 won't affect much after the x squared. So I'm really only going to focus on that for now. So the square root of 4,800 is a little under 70 because the square root of 4,900 is 70. So I'm going to go with 69. Now if I use my calculator to calculate 69 squared plus 2 times 69 plus 1, I get 4,900. So 69 does work, but it is over 4,800. So what about 68? Well, if we try that, 68 squared plus 2 times 68 plus 1 equals 4,761, which is less than 4,800, so it does not work. So the least possible value of x is 69. Now for 9,600, if I find the square root of that, I'm thinking it might be 95-ish. So if I use my calculator to find 95 squared plus 2 times 95 plus 1, we get 9,216, which works, but we still have a lot of room to go. So if I try 96 squared plus 2 times 96 plus 1, we get 9,409. It still works. Why don't we try 97? 97 squared plus 2 times 97 plus 1. It barely does not work. So the largest possible value of x is 96. Since x is an integer, it can be 69, 70, 71, 72, all the way up to 96. So you could just count that on your fingers, or we can do this very quickly. 96 minus 69 plus 1. The reason we have plus 1 is that 96 minus 69 is just the difference between the two, and it either doesn't count 69 or doesn't count 96. If you still don't understand, think about 1 and 2. 1 to 2. There's two numbers in there, 1 and 2. Except if you try and calculate that the same way we calculated the first one, 2 minus 1, that's just 1. So we need to do 2 minus 1 plus 1, which is the correct amount, two numbers. So this is what we do on a much bigger scale of 96 minus 69. And 96 minus 69 is 27. And 27 plus 1 is 28. So there are 28 possible values of x in this question. Waterloo solved this question in pretty much the same way with negligible differences. Finally, question 25. Consider positive integers a is less than or greater than b is less than or greater than c is less than or greater than d is less than or greater than e. There are n lists a, b, c, d, e with a mean of 2023 and a median of 2023, in which the integer 2023 appears more than once and in which no other integer appears more than once. What is the sum of the digits of n? So the integer 2023 appears more than once, so that means it can appear 5 times, 4 times, 3 times, or 2 times. If it appears 5 times, the list is just going to be 2023, 2023, 2023, 2023, and you guessed it, 2023. There is just one possible list for this. It's impossible to appear 4 times with the mean still being 2023, because if 4 of the integers are 2023 and the last one is, say, 2024, it is slightly off. For number 3, that means there's 2 numbers that aren't 2023, so one of them has to be above it and one of them has to be below it, just to make sure that the mean is 2023. So the order in ascending order would be x, 2023, 2023, 2023, y. For it to appear twice, this is a bit more complicated. We know that the middle number is 2023 because the mean has to be 2023. That means that there's either a 2023 before it or a 2023 after it. So it's either x, 2023, 2023, y, z, or x, y, 2023, 2023, z. Let's start with 2023 appearing 3 times. So, x is less than 2023 is less than y. Also, for the mean to remain 2023, that means that for every number that x is less than 2023, y has to be more than 2023. So, if x equals 2022, it's 1 less than 2023, Therefore, y needs to be 2024 in order for the mean to be 2023. Then, if x equals 2021, y equals 2025, and it averages out to 2023. We can keep doing this all the way down to x equals 1 and y equals 4045. For every value of x, there is one and only one value of y, so that it can add up to 4046, which makes an average of 2023. So x can range from anywhere between 1 and 2022, meaning that there's 2022 combinations with 2023 appearing 3 times. So right now it seems pretty doable. However, this is when it starts getting crazy. Now we're covering when 2023 appears twice. So first we'll do x 2023, 2023, y, z. This is the easier one. So in order for the mean to be 2023, all of these have to add up to 2023 times 5, which is 10,115. X, y, and z have to add up to 6,069 because it's 2023 times 3, and they have to be an average. So let's start off with x equals 2022. This means that y plus z have to equal 6,069 minus 2022, because we use that for x, which is 4047. And they also have to both be larger than 2023, and they can't be the same number. So the smallest y can be is 2024, but 2024 plus 2023 is 4047. So this does not work. X cannot be 2022, and neither can it be 2021. Because in this case, y plus z equals 6069 minus 2021, which is 4048. And although 2024 plus 2024 is 4048, and they're both above 2023, the question said that only 2023 can appear more than once. And in this case, a number other than 2023 would be appearing more than once. So both of these solutions have 0 answers. What about when it is 2020 though? When it's 2020, y plus z equals 4049. This can be made using 2024 plus 2025. Both of these numbers are larger than 2023 and different. And this is the only case in which it can happen when x is equal to 2020. So there's 1. If it's 2019, then these add together to make 4050, in which case the only possible solution is 2024 plus 2026, because the only other one would be 2025 plus 2025, which are both the same number. So we get 1 again. If it's 2018, they add up to 4051, in which you can get 2024 plus 2027 or 2025 plus 2026. So there's 2 possibilities for this one. And for 2019, it adds up to 4052, in which you can get 2024 plus 2028 or 2025 plus 2027, and not 2026 plus 2026, because it would appear more than once. And then, oh, sorry, 20. Sorry, I'm realizing I wrote the wrong numbers. This should be 2017, and this should be 2016. So when you have 2016, y plus z equals 4053. This can be made by using 2024 plus 2029, 2025 plus 2028, or 2026 plus 2027. So it has 3. I think you can see the pattern here. 0, 0, 1, 1, 2, 2. So the next one will be 3, and then 4, 4, 5, 5. So it keeps going until x equals 1. So when does x equal 1? Well, we start at 2020, and it goes all the way down to 1. So there's 2020 numbers in here, 2020, and this counts from 1. So it should go all the way down and have 2020 numbers, but since it's counting at half the speed, it'll go half as far. So it'll be at 1010 combinations, 1010 combinations when x equals 1. So how do we count this? Well, something I learned on this competition is that when you add a bunch of numbers in a row, there's a really cool formula you can do. X times x plus 1 over 2. So you can try this with any list of numbers, but if, say, we do 1 plus 2 plus 3 plus 4 plus 5, most people know that that's 15. If we take the highest number in this list and we plug it in as x, it'll give us 5 times 6 divided by 2. 5 times 6 is 30, and 30 divided by 2 is 15. So you can try this with any list of numbers that are constantly ascending by 1. But what about when it's only ascending by 1 every second time? Well, the list goes up to 1010, and there's 2 of each number. So, if we double it, then that means that'll give us all of these numbers added together. So, we do 1010 times 1011 divided by 2 times 2. So we can just cancel out those 2's because there's no point in dividing it by 2 and then multiplying it by 2 again. Then we can put it into our calculator, and we get 1,021,110. I told you it was going to be crazy. So going back to our original list, we know that when it has 5 times, it has 1 possibility, 3 times has 2022 possibilities, and 2 times has 1,021,110 possibilities. But that's only half of the problem. There's still XY 2023, 2023, Z, which you might think is the same, but I'm going to show you right now why it's not. So what we were doing was finding X all the way down until it was 1. So this is not the same question just flipped around, because now we're dealing with Z on the end of it, and instead of stopping at 1, Z is going up, so it can go as high as it wants. X had a limit of 1. So now we need to solve for X, Y, 2023, 2023, Z. So once again, X plus Y plus Z equals 6,069. And similar to last time, we're just going to start with z equals 2024. If z equals 2024, x plus y equals 4045. If x and y are 4045, then they can't reach this, because if one of them is as high as possible, 2022, then the other one has to be 2023, which just isn't possible. So once again, there's 0. If x plus y equals 4044, and this would be the case when z equals 2025, this would be 2022 plus 2022, which also isn't possible because it's a repeat. So also 0. So the first possibility is when z equals 2026. X plus y equals 4043. So x is 2021 and y is 2022. So there's one possibility here. And here we have the same pattern, and it will keep going, but not until x or y equal 1. And I'll explain that. So once it goes down to 10 possibilities, which was our maximum last time, what will x plus y equal? Well, last time we know that there were 2020 integers between 1 and 1010. So we need to find 2020 integers from 4043 down. And to find this, we can use a trick we learned in one of the previous questions. 4043 minus 2020 plus 1 equals 2022. Or, no, 2024. Apparently Isaac can't do math. So we can verify this by thinking, okay, 2024, x plus y equals 2024. So x can equal 1 and y can equal 2023. Then x can equal 2 and y can equal 2022. We can do this all the way to halfway to 2024, which is 1012. So 1 plus 2023 isn't possible, so it would start at 2 plus 2022, and then 3 plus 2021, and so on until the middle, which is 1012 plus 1012, which also isn't possible. So it would range from 2 to 1011, which we can find how many are in between there by doing 1011 minus 2 plus 1. There's 10 possibilities. So at this point, we can also calculate that z equals 4045. So now let's keep going with z. What happens when it's 4046? That means x plus y equals 2023, which actually has 1011 possibilities, and I'll show you why. First it has 1 plus 2022, then 2 plus 2021, 3 plus 2020, and so on until the middle, where it is 1011 plus 1012. So let me illustrate that actually. So 2023 can be made by doing 1 plus 2022, 2 plus 2021, all the way down to 1011 plus 1012, 1010 plus 1013. So all these add up to 2023, and so does every single number in between 1 and 1011. So that means there's 1011 combinations here. And then, if we keep going with z, say z equals 4047, x plus y in this case goes down to 2022, and this if we think about it, has 1 plus 2021, 1 plus 2021, 2 plus 2020, all the way down to 1011 plus 1011. Since this does not work, the highest possible value is 1010 plus 1012. So this ranges from 1 to 1010. So it has 1010 possibilities. I apologize for my messy page, but if we keep going with z equals 4048, x plus y will equal 2021. And if we do this, we've got 1 plus 2020, 2 plus 2019, all the way down to 1009 plus 1012, then 1010 plus 1011. So this also has 1010 possibilities. And then if z equals 4049, x plus y equals 2020. So this we can verify by 1 plus 2019, 2 plus 2018, all the way down to 1008 plus 1012, and then 1009 plus 1011. So it's 1 to 1009. So this has 1009 possibilities. So now we see the same pattern, except it's going backwards. So we see the growing numbers pattern in this all the way to 1009, 1009, 1010, 1010. Then it hits 1011 and it starts going down again, 2 at a time. So it's basically double the last number we had, which is this 1010 times 1011 divided by 2 times 2. Those cancel out, but then we want to multiply by 2 again, because it happens twice, reversed. And then we want to add 1011, because that's an extra number in between the two flipped patterns. So when we put this into our calculator, we get 2,043,231 possibilities. And now we get to add that to all of our previous possibility amounts. So we're going to add all this. And our number that we get is 3,066,364. So n equals 3,066,364. Now the question wants us to add up all the digits of this number. So 3 plus 0 plus 6 plus 6 plus 3 plus 6 plus 4. And we get 28. That's our answer. Thanks for watching this video. I hope it helped you out, and I hope you have a great rest of your day.